Let's take a look at another functional equation. This one is the problem 1 from International Mathematical Olympiad 1983. So the question is like find a function f from real number to real number such that it satisfies two conditions. The first one is f evaluate at x times f of y equals y times f of x for all x, y are real numbers. And the second condition is x would tend to 0 as f of x would tend to 0 as x tends to positive infinity. So actually in the internet, I have seen a solution using the fixed point technique. However, I do not use the fixed point technique, but the fixed point technique is quite interesting in my opinion. So maybe I will record another video to show you the fixed point technique to solve this problem. Anyway, in this video, I'll introduce my approach first. So let's begin. So first of all, we can simply observe that f of x equals 0 for all x should be a solution, because it's clear that for condition 1, the left side will be 0 and the right side will also be 0. So f of x is a constant function as 0 will be the solution. Let's see if there exists some value of x such that f of x is not 0. So let's see. So this is the first one. So let's see there exists f of x 0 such that f of x should be written like there exists x0 such that f of x0 is not 0. So let's first consider f of 1. So let's f of 1 to be a constant c, denote like this. So in the original equation, let's plug in x equals y equals 1. So in this case, we will have f evaluate at 1 times f of 1 equals 1 times f of 1. So on the left side, this is c, this is also c. So we will have f of c equals c. So next, also in the original equation, let's plug in x equals 1, y equals c. So we'll have f evaluate at 1 times f of c equals c times f of 1. So this one is also c. This one is also c. So we will have f of c equals c squared, which means that c equals c squared, which means c is either 0 or c equals 1. So if if c equals 0, so if c equals 0, so we can simply plug in y to be 1. So on the left side, we have f of x times f of 1. So equals, this is 1 times f of x, which means that f of x, so this is f of x, this is 0, equals f of 0 to be a constant function. And it will be 0, of course, because all the values of x will be the same value. And actually, we'll know that this one will be 0. So go back to this case. So the next case is if c is 1, which means f of 1 equals 1. So in this case, in the original equation, it turns out we can substitute x to be 1. So we will have f evaluated 1 times f of x equals y times f of 1, which means that f of x, it should be, let me see, it should be y here, it should be y here, it should be y here, which means that we have a f of y equals y. Okay, so next, in the original equation, we can substitute y to be f of y. So in this case, we will have f evaluated at x times f of y equals f of y times f of x. So in this case, this one is y, so we will have f of x y equals, we just swap this, so we have f of x times f of y. So this is somehow like the previous problem, but a little bit different. In the last video, we have f of xy equals f of x plus f of y. And we already know that f of x equals log of x with base a to be the solution to this one. Actually, this one is a little bit different, but actually we can simply use a transformation to convert this one into that one. So let's see, we can take lateral log on both sides. So we will have lateral log of f of xy equals lateral log of f of x times f of y. And as we know that natural log with multiplication, so it will just turn into natural log of f of x plus natural log of f of y. So we can assume g of x is natural log of f of x. So it turns out to be g of xy equals g of x plus g of y. So in that case, we have g of x equals log of x with base a. So let's see what should be f of x. So here we have, we should have, as long as g of x is natural log of f of x, which means that f of x should be exponential to g of x, which means we can plug in g of x to be log of x with base a. So we have a exponential to log of a x, or we can rewritten it as exponential to lateral log of x to the tth power. Why it will look like this? Because for exponential to lateral log of x with base a, we can just simply change the base by exponential to natural log of x over natural log of a. And actually, we can just move this term. We can regard this one is a multiple, so that we can put it at the exponent. So it will look like exponential to natural log of x to the 1 over natural log of a power. And actually, this one is somehow like a constant t. So we have exponential to natural log of x to the tth power, which means f of x should be x to the tth power. Actually, we can just plug into the original expression. Like original one is f of x times f of y equals y times f of x. So we just plug in this one into the original expression. So we have f of x times f of y equals f evaluate at x times y to the tth power, and then this one will be x to the tth power and y to the t square power. And then for the right hand side, y times f of x should be y times x to the tth power. And actually these two should be the same. So this one and x to the tth power can be cancelled, and which means that y should be equals to y to the t square power. So y to the t square power equals equals y, which means that if we just move this term over and then we factor out y, so we have y to the t square power minus 2t square minus 1 power minus 1 equals 0. Actually, y can be arbitrary value, so y is not 0 at least. So we have y to the t square minus 1 power minus 1 should be 0. Actually, y is also arbitrary value, but it's not necessary to be 1, which means that t square equals 1, t square equals 1, which means t square minus 1 equals 0. So t square equals 1, which means t equals plus or minus 1. So we have another two solution. One is f of 0 equals 0, and we have a t equals 1, t equals minus 1. So one is f of x should be x to the first power if t equals 1. However, this should be rejected because we have the second condition. So this is rejected due to the second condition, because we need limit x tends to infinity, f of x should be 0. So this is reject. For the other one, f of x equals x to the minus 1, which is 1 over x. So this is okay. So actually we can just plug into the original expression so that we can see f of x times f of y equals f of x over y, which is y over x. So it is y times 1 over x, which is y times f of x. So this is good. So we have two solutions. One is f of x equals 1 over x, and the other one is f of x equals 0 for all value of x to be real number. And this is the end of this video.